Hey guys, so today we'll be trying to do a quadtree, right? So first thing first, let's create the quadtree. Let's not care about the sketch for right now. Let's just do the quadtree, right? So we'll have a quadtree class. Awesome, great. This quadtree class will have well, we'll need some kind of range, right? Some kind of boundary, right? So we can create also a class for the boundary. Awesome. This class will basically just have this dot x, which will be, it'll have float x, float y. It'll also have a width and height, so let's call it W and H. If I'm able to type, okay, there we go. And then we'll set up the constructor, basically passing in all of those values. So float x, float y, float W, and float height. Awesome. And we'll just assign those values. And this dot h equal h. Awesome. So we have our boundary now. Okay, so what do we want to do in the quadtree? We'll need, basically it'll have a boundary like we said. Boundary. Is there an A? I never can seem to remember. Let me search it real quick and see. So boundary, is it with an A? Yeah, it is. Awesome. Okay, great. So and get back to it. Okay, so we'll have a boundary. What else do we want in here? We'll probably want the list of elements it contains, right? So we'll have an array list, I guess it's fine. Array list of element. And those elements, we don't know what they will be. So we can just say it's going to be E. And we can say also that E is going to be its extending, let's say, a point, right? So, because we'll need X and Y. So point, which will just have a float X and a float Y. Awesome. So quadtree E will extend point. There we go. Cool. So it'll be an array list of E. Call this elements. Let's set it up right away. New array list. Awesome. What else does it need? It needs, so basically, let me go to the whiteboard. Alright, so the quadtree is a boundary. Right, this would be the boundary. This would be the x, y of the boundary, and this here would be the w, and this here would be the h, right, the height. So this would be the boundary. This would be the quadtree using that boundary. And we will have a list of elements inside that boundary. But we will also need that quadtree to have other quadtrees, possibly, right? They are not necessarily going to be there, but most probably there is going to be other quadtrees within that quadtrees, right? So whenever we want multiple quadtrees within one, we will always subdivide it into 4 quadrants. So we'll call this top left, just lowercase, top right, bottom left, and bottom right. And those are going to be other quadtrees. So we'll need those variables, those attributes, fields, whatever you want to call them, inside our class Quadtree, right? So let's do this. So we'll have other Quadtrees as part of a single Quadtree. So we said top left, and we'll just duplicate this 4 times. So top left, top right, bottom left, and bottom right. Okay, awesome. Okay, great. So now that this is done, we'll need the constructor for the Quadtree. And the first Quadtree we create, we don't want to put anything inside of it. So that entails that we'll create the first Quadtree we create will have a boundary of possibly 0, 0, I'm thinking. Let me think. Yeah, I think it's fine. Is it though? Is it? We'll think about it. We'll think about it. So for right now, let's not care about it. Let's care about all of the other ones. Okay, awesome. Great. So we'll create it, passing it its boundary. Let's call it B. And we will also, oh yeah, and we will need a like a capacity, right? The Quadtree will have like a maximum capacity for the array list of elements, right? So let's do an int for the capacity. So int capacity, and this will also be passed, right? Int capacity. Awesome. So let's assign those. This dot boundary equal B, and this dot capacity equal, well, I can just copy boundary as well. That's fine. There we go. Let's be explicit, and over here as well, and there capacity. Awesome. Okay, great. So we have our Quadtree, and all of those should be null by default because it doesn't mean we need to create those, right? So what we might want to do is within the boundary, we might want to define a function to subdivide, right? So it could return, I don't know, let's make it return a boundary, boundary array of 4. Especially, can we set 4? No, I didn't thought we could. Anyway, and let's call this divide. Okay, great. So we will need to create from the one that we're currently in the new 4 boundaries, right? So let's do this. Let's do an array of boundaries. This will be public as well. So let's do an array of boundary, called it boundaries, I guess. New array of boundaries of 4. Okay, great. What's there here? Yeah. Okay. So the first one we will be putting in here will be, let's say, the top. So let me comment this, top left. Okay, all right. So we'll need a new boundary. And for that, so basically the X and Y of this current boundary is the top left of it. So if we want the top, so it should be for the top left one, it should be the same x and y, and it should just be the width divided by 2 and the height divided by 2, right? That's what I'm thinking. And just because I'm picky, I'm going to add this, but you don't need to, since we're not using any other h, y, x, and w as well. So, okay, so we have the top left. Now we need the top right, let's say. It's going to be 1, awesome. So, top right. The only thing that will change, so this, it's the same size, right? So this is fine, though it will be x plus width divided by 2, right? So we want from top left, well, for you it's from top left, moving to the middle to be the middle point, right? For the rest of the top right boundary. So this should be it. So now bottom left, let's do. So bottom left, index 2, awesome. So it should be the same x. The y should be this, and the size should be exactly the same as the other ones, right? So that's fine. So there you go. I might want to rethink this and put this as a variable somewhere, but for right now, let's leave it at that for simplicity. Or because I'm lazy. Both of them are good excuses. And the bottom right, it's basically going to be both of them plus half of the width and half of the height, right? But we want to move it half of its current space, like the corner point, right? There you go. So this should be it for creating the boundaries, right? And we want to return boundaries. Awesome. Okay, great. So we have this subdivide function. Great. Now, okay, over here. Boundary capacity, that's fine. We're setting the rest by default, that's good. Okay, what do we need else? Well, I mean, we could have a subdivide function within the quadtree so that it calls subdivide for all of the descendant quadtree, right? So we'll have public subdivide again, just like the top one, though this one is not going to return anything, I guess. Yeah, it doesn't need to return anything. It'll just subdivide itself, right? So we could have also a boolean for to know if it's divided or not, right? Divided, and let's set it equal to false by default. Okay, and here we'll say this dot divided is equal to true, right? That's fine. I just want to keep track of it. So we basically, if it's already divided, if it is divided, let's return early. Okay, that's great. So if it's not divided, then we need to just subdivide it, right? Yeah, okay. So, we just need to call the boundary subdivide, right? So that's what we're going to do. Okay, so we'll need to say this dot boundary dot subdivide, and is going to return a list of boundary, like we said, which we're going to call boundaries again, I guess. That's fine. And we'll need to set this dot top left equal to 0th index. Boundary does not match with local quadtree. What's the issue here? I don't know. Oh no, it needs a quadtree, right? Let me think. Well, yeah, my bad. we just need to create a new Quadtree with that boundary that got returned, right? And we'll pass the same capacity as the current one. Okay, yeah, awesome. So we're going to do this 4 times. So top left, top right, bottom left, and bottom right. Cool. And this is going to be 3, 2, and 1. Awesome. This is our subdivide function for the Quadtree itself. So creating the 4 new Quadtrees from the single boundary of that current Quadtree. Okay, great. I think we're mostly there. We're missing a couple of stuff, right? We want to insert new elements inside this Quadtree and descending Quadtrees. So we'll first need to see if any given element is inside a boundary, right? Right. So we can have a function that returns a boolean, like true or false, if it is contained inside that boundary. So maybe call it contained or contains, right? So it contains basically here it's going to be a point, right? So it's going to be the same as this over here. So let's put this over here as well. And let's do, it's going to receive E point, let's call it. And okay. So we just need to return true if this dot x is greater or equal to point dot x, and if this dot x plus this dot w divided by 2 is smaller or equal to point dot x. And we need to do basically the same thing but for the y. So as long as the y is greater or equal to point dot y, and as long as this is the point dot this is dot y plus, I don't need to divide by 2. What am I saying? Right? Yeah. I don't need to divide by 2. There we go. Should just be plus that, right? It's smaller than point dot y. Yeah. I think that's right. We'll see. Okay, so we need to know if it's contained. Okay, awesome. So over here, I'm guessing when we create the boundaries here, new boundary, we'll probably need to pass it E. Or do we? Yeah, let's pass it E, I guess. Okay, I think that's fine. No errors. I think we're good. Okay. All right. So, yeah, never use loop. Yeah, that's fine. Okay, so we need some type of insert function, right? So it's going to be inserting E, let's call it point again, into this or subsequent Quadtrees. So okay. So, right, my bad. All right, so we need to check if it is if the point we're passing is not within the boundary of that current quadtree, we can early return false, right? So yeah, that's not, yeah, we'll do this subsequently within itself. So we'll need to return boolean to know if it has inserted it inside of itself. Okay, so if the point is not contained inside this boundary, so this dot boundary dot contains the point. So if it does not contain the point, we don't need to do anything further. We can just return false, right? It hasn't been inserted. Awesome. Okay, next. So if the capacity is still there, if there's still capacity left, and it is inside, which means contained would have returned true, then we can add the point to the elements, right? Yeah, I believe so. Okay, so if this dot capacity dot size is no, not capacity, this dot elements dot size is smaller or equal to capacity. We can do just smaller, that's fine. Okay, so if there is still capacity inside, then we want to add that element to the quadtree. So let's do this dot elements dot add point, and let's do return true. Because we did insert it, right? Awesome. Okay. Next, if the capacity is full, then we can just check each of the quadrants of that quadtree and see if those can insert it, right? So yeah. And we'll by default return false. Okay, so if the top left, so wait, let me go there. Insert, there we go. So top left we said, so if the top left quadtree dot insert the point, then we return true. And we do the same thing for all of them. Oh, and one thing I almost forgot, we need to make sure that they are divided first, right? That we do have those, right? Because by default they are null. So we need to make sure that, let's say if this dot divided, if this is not divided, let's do this dot sub divide, right? Okay, now at this point we should be sure that these exist, right? They are not null. Yeah. Okay, so though we don't want only top left, so top right, bottom left, bottom right. Awesome. So we're pretty much done for the insert function. So now we did insert, we did subdivide, we did contains. So the goal of the quadtree essentially is to be able to query elements within a certain range, right, of a boundary. So we could have a query method within that quadtree to see if any given points, or to get all of the points or get all of the elements within that boundary that match a given range. It's a mouthful. Alright. So I'm going to copy this over here, though I'm going to call it this time range. It's not going to need this, but the rest should be exactly the same. So our range will be a rectangle of some kind at some x and y position. Okay, great. So in the Quadtree, over here, it's going to return an array list of element. We can call this query, right? So query is going to receive the range. Does it need anything else? No. Not for the time being. Okay. So we'll need the range, and then with the range we need to see if our current boundary match that range, right? So if the range is, so let me get back to the whiteboard. There. Okay. Where's my marker? Here it is. So let's say we want to query here, right? So this is our range. Right, so this is the range we want to query. We will have to first pass the range through this whole quadtree. This quadtree needs to check if the range is intersecting with the boundary of that quadtree, right? So we'll need to do like quadtree. And then we'll need to check the boundary, and then we'll need to check if the boundary, meaning this full rectangle, intersect with our range, right? Because if our range was here, then we don't need to check any further than this quadtree, right? We check the full quadtree, we see that this is not within this, so or it's not even intersecting with it, so we don't care, right? So we need to check the boundary intersecting. Okay, right. So just making sure you can see. Yeah, that's good. So we're going to check if the boundary itself intersect with our range. Then if it does intersect, we need to add to our list that we return all the elements that are within that quadtree. But we also need to check after that, we also need to check the other quadtrees if they are present to see the same exact, to basically we'll call the same exact query function for the other 4 quadtrees, right? So for top left, top right, bottom left, and bottom right, we'll need to call query on it. Great. So I'm thinking we need to have an intersecting method for boundaries. So we'll create that. It's going to receive a range, basically. So let's do that. Okay, so let's not care about this for right now. Let's go back to the boundary and let's create a function that returns a boolean, right? True or false. If and let's call it intersecting with a given range, right? And this will be public as well. Well, I don't need to put public there. It's public by default. So let me just be consistent, get rid of those. Awesome. And let's do the same for this. It doesn't need to be there. It's good to have it, but definitely not needed. Okay, awesome. Okay, great. So let's get back to our intersecting, right? So we receive a range. So we need to, first thing first, return true or false. It's going to be similar, not exactly, but similar to this. So what we need to check? We need to check if the most top left corner we can just check if any of the four corners of the range are within that current boundaries. That current boundary. Yeah, I'm thinking that's the easiest way in my mind to do it. There's probably more efficient ways, but it doesn't matter. Let's do that. So let's write it the long way, right? So if return true, this will be for top left of range. Yeah, so okay, so we basically need to check this. Could we just use contains? Well, I mean, sure. Anyway, it's fine. I'm not going to. Do we need four corners especially, or we could just check both sides? Yeah, let me think about it. So let me remove this. So we know that if the range dot x is greater, so this is the top left. Well, this is the most left value. If the x is greater than the greater than or equal to this dot x and wait. Does that make sense? Let me think about it. I think it does. So if this dot x is greater than, I mean, we really could just call contain for time, right? Yeah, sure. Let's do that. So let's do that. So yeah, I mean, sure. If this dot contains the top left, yeah, let's go with that. The top left point of the boundary, which is at, we can make the range extend the point so that we don't need to, no, we'll need a new point. So the range dot x, range dot y. So if this point is included, do I have one too many curly braces? No, I think it's fine. What's the issue? Contains expect parameter of type E. Oh, right. Let's do another one. Sure. Should I just pass XY? Possibly. Yeah, I think I'm going to do that. I'll just pass XY values. E is not even going to receive anything. It'll just receive X and Y. Both of those are going to be floats. Okay, awesome. It won't be point, it'll just be X, X, Y, Y. And I will not need this anymore. Yeah. Too complicated for just what it should be. Should be pretty simple. There we go. Yeah, let's go with that. Okay, great. So if this point is contained, we return true. If any of the 4 points are contained, we return true right away. So well, let me think about it. Let me go back to the whiteboard. There we go. So this is our boundary. If we have, let's say, this here, we know that we need to check the boundary. We know that it is intersecting because this point is in here, right? If the range is over here, then we know that it is intersecting because this point is in here. If this range is in here, we know it's intersecting because this point is in here, right? And if this is in here, we know it's this one. And it doesn't matter, this one, it'll be finding this point first, right? Because we have the top left if first. Yeah, I think that logic makes sense, right? Sure, let's continue with what we were going for. So, let me get back to this. So we did the top left. Just looking at the board. So let's do the top right, which is basically just going to be the width plus the X plus the width. Range dot W. Awesome. Then let's do, so this was top left, this is top right. And then let's do bottom left. So bottom left, basically the same, the W plus Y plus H, right? Y plus H. Range dot X. Yeah, right. And then it's both of them. Okay, if none of those are true, sorry, we return false. Okay, think we're good. So we have our intersecting function. So let's go back to our query. Okay. So what we said we call on ourselves. So we'll need to check if this dot boundary dot intersect. I should just call it intersect, not intersecting. What did I call it actually? Intersecting. I'll just call it intersect. If this boundary intersect with the range, then we need to add to our list. So we need to keep track of a list of elements, right? As we dig within Quadtrees. So we'll pass this as a parameter to the query. So yeah, okay, sure, it's fine. And I could technically not make it return anything, which I think should be fine for our purpose. So yeah, let's make it return void. and let it make it be so that this would be elements, let's say, right? So we'll have elements dot add all of the current elements, right? Of the this dot elements inside of it. So sorry, just making myself comfortable. Okay, awesome. So is there a way to concat? Let me get the references. Awesome. Let me get that here. Okay. Let's look at well, I don't need I need Java array list concat. There we go. Add all. Awesome. There you go. Add all is something that exists. I didn't even know. Add all, expect collection. Awesome. That's great. Add all of this dot elements. Great. Okay. So now we need to check if this dot divided, like we said earlier, right? If we take a look at this, to the right we see if it is divided, we need to basically call query again for all of those divisions. Okay, great. Let's get back here. Okay. So if it is divided, well, I mean, if it is not divided, we can just return. And if it is, then we need to do this. Well, I need to just call this dot top left dot query. And let's pass the range and the elements. I think that's pretty much it. Let's copy paste a couple of times, one too many, I think, yeah. And then top right, bottom left, bottom right. Do I need anything else? I think that's it. What's the issue here? The function contains expect parameter like float. Oh yeah, okay. Point dot x point dot y. Okay. Any other errors anywhere? No. Okay. So let's create the different files for the different classes. So we have point. There we go. Let's paste this in here. We have range. Whoa. We said we have range. Okay. Range, there we go. We have boundary. And we have Quadtree, which we already have the file for. Okay, awesome. Great. Now, let's finally write something that we can see. So void setup. Void. Do I need draw? Well, let's not. I don't need it for right now. Not for what we're doing. We'll have one Quadtree. Oh, I need still to think about not Quadtree, but Quadtree. I still need to think about the first one, right? Or does it really matter? I don't think so. Yeah, I don't think it does really matter, right? No, I don't think it matters. Yeah, the first one should just be the full screen. Okay, yeah, never mind. Okay, and we'll have an array of points. Cool. Let's call it points. Okay, great. In setup, we'll set full screen. Why not? We will then populate the points. So we'll say like 500 points. Less than 500, we said. 5++, there we go. Okay. Okay, now we need some random x, random y, random between 0 and width, and then same thing for y with the height. Then we create a new point, so and we push it right away in here. So points dot add new point at xy. Okay, we're good. What's the issue? Point does not exist. Point float x float y. This dot x, this dot y equal to y equals to x. Okay, awesome. Now it shouldn't have any issues. Okay. Now we need to create a boundary. Like this is the only one we'll be manually creating. Well, yeah. And it'll be the boundary for the full window size, right? So boundary, new boundary, it'll be at 0, 0 to start with. So corner, top left corner of the boundary will be 0, 0. It'll have a width of width and a height of height. Okay, awesome. Now, this is just not used. What's the issue? Local variable boundary not used. That's fine. Now we'll need to create a, well, we already have the Quadtree. Well, yeah, okay. This, we can move it. Oh, no, we cannot. Well, yeah, I mean, I can move this over here. Sure, it's fine. Okay, cool. So we will need to create the Quadtree. New Quadtree. What does the I think it just takes the boundary and the quantity, right? The capacity, right? So let's say 5 or something. Okay, and then let's draw all of our points. Well, no, first we need to add all of our points. And yeah, so let's add all of our points. So for point P of points, of points, let's add them to the Quadtree. So Quadtree dot, what did I call it? Insert, something like this. I don't remember. Insert, yeah, it was. Insert, and Quadtree will be over here. We can say boundary Quadtree will be point, and I mean we don't need to pass it, but I can. Yeah, it's fine. Point. Okay, great. So insert P. Okay, that's it. Now we can query, right? So let's have a range. Ooh, yeah, sure. And let's set it like to the middle-ish of the canvas, right? Or whatever, it doesn't matter. New range at, let's say 300 by 400, and it'll be like 400 width and 200 height. Okay, and now let's do Quadtree. We'll need to we'll need like an array list of points. Call it queried or found. Sure, found. New array list. That's it. And then we need to do quadtree.query with the range and the array. I think we're done. Let's just show it. So let's do something like, I know there's a lot of loops in here that are not necessarily needed, but it doesn't matter. Let's do points for each of the point. P.x, P.y, and let's do the stroke white. 255, awesome. And let's do the stroke weight a bit thicker than 1, just because maybe 3 or 5 even. I think 5 should be fine. Okay. And let's do this again, but with, I don't know, like a reddish tone. I don't know. Not the best with colors. And this will be the found. Okay. And let's, while we're at it, draw the range as well. Let's do no fill. And let's draw the range. So range will just be a rect. I believe it should just be the range.x, range.y, range.w, and range.height. I think that's all it needs. Okay, let's try it. Okay. We've got our points. We've got a range drawn. Though the points that should be reddish are not reddish. That's concerning. Let's draw a background as well. Well, okay, there are some issues. I'm pretty sure there is. Let's stop this. Let me see. So points found, p.x, p.y, that's fine. This seems to never stop, right? The query. Well, no, because it gets to here. Did I mess up something in the quadtree when we query? If it intersects the range, then we add all of the elements. Do we want to add all of the elements? I don't think we should. It needs to, well, should we? Let me think. No, adding all of the elements here doesn't make any sense. Well, no. No, we should check if the boundary contains each of the point and add them separately. Yeah, I think I'll do that instead. So we'll do for points, or for e of lms if this dot boundary dot contains right. Oh yeah. Oh yeah. No, that wouldn't change anything. think we would want the range to also have a contains function, right? Let's copy this, let's put this in here. Contains, yeah, that's fine, that's fine. Let me go back here, range, yeah, okay. Let's go back to this, no, sorry, to this. If the range contains the given point, which would be e dot x, e dot y, then we do elements dot add e, right? Let's also try to draw. Okay, well, let's see what does this give us. Same thing. No differences. Okay. Okay. Let me think. Let's add to the Quadtree a show function, maybe. I think we're close to it, but doesn't seem like we are there yet. Let's do push matrix. Let's do stroke like this. Rect from this dot boundary dot x, and let's copy this. Okay, this is the boundary dot x, this is the boundary dot y, this is the boundary dot w, and this is the boundary dot h. Okay, and let's do pop. Well, do I really need this? I don't think so. Anyway, it's fine. And if this dot divided, and let's do the show for all of them. So I'll basically copy one line of this, show, top left, top right, bottom left, bottom right. Okay, I think it's fine. Let's, oh well, I didn't call show, that's not really useful. There is an issue. Yeah, I guess. Give me 1 second, I'll be right back. Alright, so I figured out 3 issues right now. First issues. First issues was in the boundary contains method, which was doing this everywhere. I needed to invert the signs, right? Which makes sense. I just don't know what I was thinking, but that's fixed. I also fixed it here since I copied the same. Okay, so this is fixed. Then I was noticing in insert, it was giving us a null pointer. It was telling us that we could not call contain on a null value. This boundary was null for some reason. So I checked out why it was null and figured out that here, whenever we call boundary that subdivide, it should return us 4 elements in the array, right? So I went and checked into here and I saw this. So this I fixed as well. So that's pretty much what I did right now. So it's not working properly. at least now the quadtree gets divided properly. The query doesn't seem to be working properly, but that's another issue. So yeah, let's see why exactly we have that issue. So we're getting points that should be in there, that are there, but not all of them are there. So what's going on here, right? Let's see. Let's quit this. Okay. This I don't need to print it anymore. Where do I do print? Print is it in here? Not in here. Oh, I think it's in here. Yeah, this I don't need anymore. So our query function, it works but not properly. So we need to check. So we are adding to it. I'm questioning whether this is doing its job properly. Well, intersect. Let's take a look at intersects over here, right? If this is contained, that's returning true. So it's an OR basically, which makes sense. That's fine. Quadtree. Let's see. So range that contains, okay. So if it's not divided, we just return, that makes sense. If it is divided, we do top left dot query, we pass in the same range, and we pass in the elements that we currently have, and we should be, it should be updating elements, right? So if I were to print this, it should have the same hash every time. It should be the same exact object, right? So if I did this and then went back in here, yeah, oh, well, no, it's weird. Oh no, I mean the array's fine. So first time we're passing in, we're finding 0, 0. So 0 on the first one, and then the second one, which should be top left, we have nothing. And then the third one, which is this one, we have 2 elements. And then we have 2 elements until this one, then this one. Why is it only finding a couple of them? Oh, I'm stupid. Let me get back to the whiteboard. This here is flawed. Yeah. The intersect function is flawed, right? Let's say this is our boundary, right? And we have 4 other boundaries. So boundary 1, boundary 2, boundary 3, 4, and 5, right? Let's say I have, oh, and let's do other ones, right? Okay, let's have it like this. Sure, it's fine. So I know what's going on. So let's say I were to draw this range. this boundary here is not going to be looked at because it doesn't think it's intersecting, right? None of the points are inside of it. But it is intersecting because it is on top of it. So let me erase something. I need to rethink of the intersecting function. Okay, how do we want to do this? So, yeah, it's fine. So, let's say we have this like that. And like that. Okay, fine. Let's say I have this one over here. Yeah, sure. This one is intersecting with it, right? But right now it's not, but it is. So I know it's intersecting because range.x is smaller than, so range.x is smaller than the boundary.x, while the range dot y, right, is, let me think about it. Let me erase everything. It'll be easier on a bigger scale. I really need to clean this, but anyway. Alright. So, oh, now it's wet. Okay. Anyway, let me try to do this, and I can explain it maybe after. Let me think. So I need to see if the range.x is smaller yeah, I don't need the contains. Go here, intersect. Okay, let's do it again. So if this dot x is greater than the range dot x, or if this dot no, if this dot x, yes, if this dot x is greater than the range max, or if this dot x plus this dot w is smaller than the range dot x, or same thing but for the y, I believe. I think. I mean, we'll see. Let me remove all of this. Let me directly return this. Let me put it back in here. Let me try this. No. Okay, let me do this and I'll come back and tell you what I did. All right, I had it right. I was just missing not, right? So this was not intersecting, so I'm checking if it is intersecting. Yeah, why did, yeah, there, okay. Now, working properly, right? There we go. Okay, yes, we got there in the end. Awesome, awesome, possum. Okay, okay, great. I will do one quick last thing and then we'll be on our way for the win. So we'll have the draw function over here. And this draw function, I basically wanted to do this whole thing. Created a remove as well. I was just debugging with it, but I don't need this anymore. Okay, great. Let's go back here. Let's put this in the draw function, and what I want to change though is over here, this would be mouse x and mouse y, and then let's do width being let's do minus 100. Oh, not 1000, minus 100 as well. 100, and let's say 200 by 200. Okay, let's see this now. Okay, I need to redraw the background for sure. Definitely, and let's see after that if it does work as expected. It should just be exactly the same as before, but now, yes, awesome. We got there in the end. That's amazing. Oh, that's great. Oh, I'm happy. It took so long, but we got there in the end. Let me maybe make the, I don't know, the max count of points maybe. Oh, and do I need to, well, I don't need to replot all of the points. Let's do maybe a minimum of, let's do a minimum of 15, right? Let's do this. So now there's a lot less quadtrees in here because there's, yeah, that's great. It's working. Amazing. Just amazing. That's awesome. Oh, I'm so happy. All right, then I'll leave you with this. This will be used in the future, in future videos, so it wasn't time wasted. It's definitely going to be useful in future videos. Thank you for watching. Hopefully you enjoyed it, and hope you enjoyed the video. See you in the next one.